can start? Okay, cool. Yeah, so hi everybody. Good morning, good afternoon. So it's been a little delayed because I just arrived a couple of hours back, so it took a while to come here. But yeah, I think this talk is mostly about Web3 security and AI, how you can actually use both of this together, and how this can help you to become like a much better in terms of security. So why we're talking about this, obviously we understand security is growing. The problem is actually increasing on a day by day. And it's not only a single, so take a step back from Web 2 versus Web 3. We're talking about industries. Like every industry has problems in terms of security. Data breaches happening, money is getting stolen across the industry. So it doesn't matter whether you're building a healthcare product or DeFi product or probably something else. Uh, the threats are real, right? And when you look into geography, obviously we see this region obviously has higher, and then obviously the other region also has. So there are a lot of growth in terms of geography, in terms of domain-specific target. And if you talk about especially the space we are in, Web3 space, we've seen billions of dollar growth in terms of money gets stolen. And when I say this attack is a mix of fraud, scams, technical attack, non-technical, phishing, social engineering, everything. So overall, this actually has a lot of issues, and definitely we know that there is audit, there is compliance and all this there, but then still that's not solving the problem. So what is the next step we can do? How we can create various kind of tools for which we can use for our own benefit. So a little bit about myself. My name is Tamaghna Basu. I'm the founder and CEO of DeTaSECURE. We are a cybersecurity company. Earlier, I built a Web2 cybersecurity company, financial fraud detection in the banks and all this stuff. And now we are more focusing on Web3 industry. So essentially what, as a company we built, and that's kind of the background of how we ventured into Web3 security and how we envision the kind of future roadmap about this security aspect. So what we see is, when you talk about security, it's a very generic word. And primarily we see there are two parts of it. One part is audit, and another part is monitoring, the fraud monitoring, transaction monitoring aspects, right? And now these two are being handled in two different problem statement. But think from a project sponsor. If you are building a product, if you are actually a person, founder of a new protocol you're building, all you care about is your product secured or not at the end of the day. All you care about whether you need to you have done enough to actually protect your data, protect your users and their data, their value, their money, and their whatever they have invested. So we see that security is a journey. It's not a single problem statement from the beginning till end. So before launch, you need different kind of security like audit, all this kind of vulnerability detection. But post-launch, you need different kind of security, which is fraud monitoring and aspect. So with this vision, we have built this product. And again, all these modules we have built are open source. We have actually kind of published it in the public where people can use it on their own. And as part of that, obviously, we partnered with a lot of foundations, and we kind of try to build it as partner solution along with different kind of protocols and all. And let me walk you through my journey, how we got into this space. So the first product we have built something called behavioral biometrics or behavioral analytics. So what does that mean is, this is my encounter with AI, and let's say how I fell in love with AI. I'm a techie, obviously, I'm a developer, builder. Now, 10 years back when I started my first company, we wanted to solve the financial fraud problem for the conventional world. And there is already a lot of rule-based architecture built, and that is exactly what is happening in Web3 world today. If you talk about chain analysis and other various kind of platform which is used, they do transaction monitoring. And the first step of transaction monitoring is define various kind of rules, right? Let's say blacklisted, sanctioned wallets. Are you doing transaction with some suspicious kind of entities or not? Look into the volume of transactions, rug pull detection, whale alert is all about various pattern of detection, right? Is this going through the normal pattern, and do we see a spikes in terms of transactions? It could be a frequency of transaction, it could be a volume of transaction, etc., etc. So those rule-based architecture is already been in place. It is solving the problem, but still we see a lot of challenges, a lot of frauds are happening. So we looked into that, okay, what is the gap there and how we can solve that problem. So essentially what we realized that, and eventually it come down to identity. Majorly, one is obviously you are actually having a kind of entity which is by nature suspicious. If you're a hacker or probably someone with a wrong intentions, obviously you will steal money. That is there. However, the lot of incidents happen where the identities get compromised. Your identity gets compromised, your wallet gets compromised, money gets stolen from there. Whatever is the reason, it could be a phishing attack, social engineering attack, or maybe a man in the middle where someone sniffed your private key or something like that. So we kind of took that as a challenge, and first level we say how we can protect identity with different other factors. It's not about no longer password, it's no longer about multi-factor authentication. How we can do it. So the first stage we did is we kind of looked into something called behavioral analytics. Now anybody heard about this term, behavioral analytics? Okay. So what essentially it does, it has various aspects. So we kind of started with a very ambitious initiative. Can someone guess which movie is this? Anybody? It's from one of the Mission Impossible movies. It talks about the walking pattern analysis or gait analysis. So the person walks through the vault, it analyzes the walking pattern of the person and sees is this the same person or not. So this is called gait analysis. So there are different kind of AI model you can build around gait analysis based on template, machine learning, and which can actually identify you as a unique individual based on your walking pattern. Because what it says that your walking pattern is unique. This has also been built as a computer vision problem. People have created a lot of analytics on computer vision, which captures through camera your walking pattern and does it. But what essentially we have built a model which actually sits on your mobile. It can be integrated to your mobile applications of web, which actually sits on your mobile, and it captures the sensor data, gyroscope, accelerometer data when you're walking. And based on that walking pattern, it can identify that is it a unique person, same person or not. So we kind of created various kind of model around that. And idea was this can be a very simple SDK library which you can integrate to any kind of wallets, any kind of mobile app where you wanted to protect your identity. So tomorrow, hypothetically, let's say if this model is integrated to your wallets and again, the idea was even if your private key is compromised, someone actually stolen, and I import it to my wallet, but then because my walking pattern is different versus your walking pattern is different, we can go ahead and predict that this is not the same person who is using. Now there is lot of race conditions, lot of boundary edge conditions are there. What if I'm drunk? What if I'm injured? What if I'm kind of running suddenly? My pattern changes for whatever is the reason. What if over the age pattern changes? Right, aging is also a factor. Right, your mental health is also a factor. Are you tensed? Are you relaxed? Like that. And forget about all this. The biggest problem is mobile's orientation. The orientation of a mobile in your pocket. So there's a lot of things are there. So although we get like 98, 97%, 93 to 94% accuracy, we realize that this is not a scalable solution. Because if as a startup, as a small company, we wanted to address all this problem, this cannot be solved. But the good part of this solution is the data stays in the mobile. So it's basically the privacy is preserved. So that is one of the core fundamental of what you're building, right? Now we move to the next kind of behavioral aspects. We say, there is a simpler aspect also is there called keystroke dynamics, your typing pattern, how you type. That's also unique. So this looks like a quite stable model. We've built it. We've kind of started with a Web2 world where we have kind of mobile banking, internet banking kind of solution we've integrated. And Web3 world also we are kind of offering this to a lot of wallet companies to do that. However, the idea is this is a very well researched algorithm. The models has been open source, it's been published, a lot of white papers are there. If you want to kind of build it, you can actually build a model around that, and that is very easy. You can now integrate to, if you're building a wallet or any kind of mobile app, integrate that with you to protect their user identities. Now again, I'm not saying this is going to give you 100% security, but this can give you one extra layer of analytics which can help you to protect maybe 80% of the current spectrum of attack which is happening there. So this is like how you protect identity on that. Now the other region is gestures. gestures is another very interesting factor, which we didn't realize when we actually are doing this research. But we realized that even on gesture, like how I swipe, how I probably kind of swipe up, swipe down, and holding pattern. I am holding the phone in two hands versus I am a person who hold the phone in one hand. There are different kind of this kind of, we call it like a metadata or like a additional factors we kind of identified and realized that is also can be used for this kind of identity protections. So essentially, this is called the behavioral analytics aspect, where you can create a lot of keystroke dynamics and gesture-based analytics, which help you to give you a lot of protection on your identity level, on your end user wallet or applications. So with this, obviously, we have built kind of a scoring algorithm. But however, as I said, these are all kind of, happy to share all the data what we have, if any of you are interested also. Now, while doing it, and I come from a security background, I realized, this looks like the defensive side of fine. Let's see how we can use AI for offensive aspects. So kind of I tried to create a lot of research paper and understand that, although thanks to ChatGPT today is much easier, I'm talking about much back, before the GPT world, which got released back in 2020, can I create a clone of myself using AI? So essentially what I've created is a bot, which looks like me, talks like me, it sounds like my voice, and then obviously it responds with the same amount of humor, same amount of, let's say, kind of attitude which I generally respond back. And there's a historical data we have used it. So what it is, this is again an open source project. We have published all the repo, how it's been done, the step-by-step walkthrough which you can use. But when I built it, there was no ChatGPT there, so we used something, the old kind of GPT-1, GPT-2 kind of model which you have built. But the same architecture can be used, which can be integrated with, let's say, Telegram or WhatsApp, using Twilio or any other kind of API. And you can actually create a clone bot of yours, which can be used or misused, right? Used because then you can actually create this as a knowledge bot, as a bot like which you can feed in a lot of your knowledge and help scale your solution in terms of FAQ, support, etc. On the same time, this can also be misused by social engineering attacks or phishing attacks kind of thing. Now, these are some social proofs where some people actually kind of thought that they're actually talking to me instead of talking to the bot. Now, why I'm saying this? Because this was the research I did when during the COVID period. There was nothing else to do, sitting at home, so let's do it. But when I kind of realized this aspect of, let's say, adversarial AI, I've realized that this opened a new era, or new kind of door to a new world of attack vectors. That's what I call it. Now you can be as innovative as possible, create different kind of attacks, and that can actually scale up in a multi-layer, multi-stage attacks, right? And I kind of deep dive into it. Again, these are the few. If you want to take a screenshot, these are the links of the slide, the talk, the GitHub repo, and everything, where there's the kind of process we have created. Now what we understood with this is, there are different kind of attacks you can actually simulate and create. Now, when I'm talking about attack, think from a hacker's point of view. We're not talking about specifically Web3 right now, because there are a lot of kind of attack which is very much similar and applicable to, doesn't matter which industry. Or for example, phishing attack it can apply to any kind of targeted organization whom I can target. Now, what is the payload I'm delivering there and what I'm kind of trying to achieve through the phishing attack might differ between, let's say, company to company, or what is my objective. For example, here probably my intention is to steal your private key, versus somewhere else I might wanted to just compromise your account and get your password, right? But essentially what I've realized that now you can use AI to bypass AI. You can use AI to actually create a lot of model which can actually trigger certain attacks, and that can actually kind of make use of various data points to fool you. And essentially, I've created also a workshop around that. And the idea is we can actually do bypass facial recognition, spam filters, bypass any kind of bots, which does a gatekeeper of different kind of channel, like Discord and this and that kind of thing. You can do bypasses. So this kind of is very scary, but obviously I don't teach it anymore, because I kind of found this very scary in terms of these attack vectors. Now we try to create a lot of model around that. Now, while I'm doing it, on creating all this kind of model, we realize that the Web3 space growing massive in terms of attacks. And we see this whatever pattern I've been actually thinking, let's say capture or a bot detection, human detection mechanism, which has been used in a lot of Web3 projects to prevent bots to access your protocol, and it's very easy to bypass them. So that is where we actually moved into this and say, okay, why don't you try to defend that? And coming back to kind of what kind of various data points we see kind of obviously billions of kind of money is getting stolen. Even in 2023, we see that its market was not good, but then kind of almost more than almost $2 billion worth of scams and hacks happened. Now, even in 2024, it's been what, like just a couple of months now. Even here also we see that kind of in 2 months time, more than $500 million, 500 million plus, or like $500 million kind of dollar worth of money is stolen. And if you see, these are not the exhaustive list. Obviously, these are like few of the things we can see. Apart from that, there are a lot of other attacks there. If you're from, how many of you are from security background here, if I may ask? Okay, 1, 2, 3, 4, okay. So you guys probably are doing a lot of analysis around that, but when you look into the kind of attack methodology, or we call it modus operandi, right? How it's happened or what exactly been happened here. A lot of times it's not a very complicated attack methodology, and this is very similar to what we have been seeing as an attack vector in the conventional world, which I was talking about. How we can use AI to actually create those attack vectors. So in a nutshell, this is the few top kind of attack options which I've seen, like unauthorized access, which is basically access control was not there proper in different layers, be it smart contract, be it the centralized infra, decentralized infra. That's got social engineering, definitely stealing private key through social engineering attacks and all this stuff. Price manipulation, business logic bypass, and then reentrance attack. Now, obviously the question comes, probably reentrance attack is one of the most popular one, one of the pretty old one, and a lot of time people say that this attack is no longer valid, or probably is not kind of there. But then when you look into some of other data points, and this is like one of the repository which has been kind of published by like this person, which is a historical chronological list of reentrance attack happened across all the entire Web3 world. And you can see that although this is a very popular, very well-known attack, we know how it happens. There are a lot of detection mechanisms there. We still see this attack is still there in the industry, and there is a lot of kind of attack happened. And this repo is good because it actually has indexed all the contract, victim contract, exploit contract, a sample exploit contract, which you can use, the transaction histories and everything. So this could be like a repository where you can look into that, how this attack happened. Now, obviously, reentrance had different variations, which you can actually understand and learn more further. But the point I'm trying to say that something which is pretty old, pretty kind of there, is still valid today, and it still works. Now the question is why, right? Is it like the audit not been done properly, or is it like maybe I don't know the answer, like why? Because to my understanding, a lot of time this is something which is going to be like one of the first things being taught as a smart contract audit security courses, right? How you can identify reentrance and what happens. So, but then this is happening. Now, why it's happening is a different discussion, what went wrong there and all this, but definitely it is there. Now, why I'm saying is because something like that is very simple in terms of pattern, which can be trained using AI. So essentially what you could do is, there is a possibility you can actually create a model which has this idea you can train with these various patterns, and that should be able to identify a lot of this kind of options. Now, having said that, obviously a lot of existing tools, static analysis tool also does this kind of pattern analysis. So, so we can actually kind of look into Slither and other tools which has done it. But then the first part was, create a model. So the first stage, what kind of we try to do is actually, let's create a supervised model. Now, how many of you are familiar with machine learning? Supervised model, unsupervised model. Okay, got it, right? So supervised model is obviously where we train data, right? So the one easiest option of creating a model is you actually, and this is pretty easy, you can find, let's say, plethora of vulnerable contracts. You actually flag them, do the data cleansing, create, identify the code, and you can do a different level. You can do it on a high level code, static code level, or you can do on a compiled code level. Create like different code sample repository of yours. What is a good code version? What is a bad code? What kind of pattern is there? And this is like one of the exercises we have done where we kind of created samples. We have kind of labeled them in terms of bad code versus good code. On specifically on one vulnerability, like reentrance. Like that, we have created a repository categorized by different vulnerabilities, and we have trained various models along with that, right? So first part is actually the data collection, consolidation, cleansing, and labeling properly, which is any machine learning problem. If you go, that is the first part of it, like data engineering, you may call it, right? So that itself takes quite a while time, because if your data has not been properly structured, your accuracy might get impacted. And this is a continuous learning process. It doesn't happen in day one itself. You get the right data and you can do it. You do something, you understand, then you change your pattern of data. You understand that that might improving your data and all this. So essentially, once you get this kind of data, we tried with various model. And if you know the classifiers, various kind of classifiers are available, from binary classifiers to KNN to kind of decision trees and all this. So we kind of created a different kind of model. And we have done a split, 70-30 split. You can do different kind of splits also, like 70% data used for training, 30% for test, and that also you can do randomly, you can, sampling of that data and all this. So with the data, you actually try to train and test your model, classification model. So essentially, people who are not familiar with, let's say, the machine learning, trend test is nothing but you actually split your data set into halves. Majority of the half you take to train the model, and the other part you use to test it, which is like, looks like an unknown data set to your model, which model hasn't seen it. And then it will try to feed in and see how much accuracy I'm getting. Because the test data, you already have leveled it. You know what is the right and wrong. So you actually try to, based on that, what the model predicts, and you can see that is it kind of predicting in terms of false positive or false negative, or actually the right. So this is something kind of, the first exercise we have done. This is again, we're not getting to LLMs yet, but the simple classification and risk scoring. We also kind of come up with a probabilistic model around that, saying that, okay, I classify this, but what is my confidence score in terms of I know whether it's bad or not. So there are two layers of stages of validation we have created. First level is you classify it in terms of is this vulnerable or not, and second is what level of confidence I have, and you can set a threshold. Let's say that if my confidence level is not more than 60%, I will not consider that as a valid decision, because my model is still learning, right? So first level is prediction, classification. Second level is evaluating based on your risk score. So with this kind of approach, you create a model and you try to test it out. And obviously what you try to do is we kind of integrated that into entire pipeline of your code CI/CD in terms of code deployment in blockchain. So what essentially that means is, let's say you're using Remix, and with Remix you're writing a code, and then you're eventually deploying it on probably one of the EVM chain testnet or something like that. So now you can create a different layer. You can call this model at probably as you create a plugin and an ID level, versus you can do it as a create like this as a like a MetaMask snap, and you can call it from the wallet layer when you're signing the transaction and probably deploying it. Or you can actually create this as a GERD module in base, native to your blockchain kind of thing also create. So essentially this was one POC where our vision was create a secured blockchain. So we are kind of natively integrated inside the blockchain, which is actually with a JSON RPC interceptor. And it actually, the moment you try to deploy the code, it figure it out, is this code bad or not? If it is bad, with a certain threshold, it actually kicks you out in terms of doesn't let you deploy the code. So in a nutshell, essentially the idea is first you create a model and you test it out with different kind of data set. And then after that, you try to create various hooks in terms of where you want to call the model to actually deploy, figure it out, it will work or not. So I don't know if it will work. I have a small demo how it works, but let's see. Okay, it's not visible, I guess. But essentially, on the left side is what we have the remix voice, and this is like a sample of reentrance attack which is there. And on the right side, we're trying to kind of deploy it where the code is kind of get evaluated by the model. And on the down here, if you're not able to, but this is where actually you get a confidence score in terms of what is the confidence score of a decision, is it right or wrong. And as a result, we actually can actually decide based on the score on confidence that is it good or not, should I consider the decision or not. So so again, this is the first part which kind of we have created as a model. And as I said, the overall the vision we had is how do we secure the entire journey of development. Essentially, that was the idea, because as I said, as a project, you need different kind of security and different layer. As a developer also, you will be using it in different levels. So essentially, it's not only about the model, but how you utilize the model. What are the kind of various kind of access point you create around the model to make it very easy, very easy to use and to adopt, and very seamlessly it integrates through your development journey. Because one problem we have seen in my experience is security is always considered to be a friction in terms of development, right? So something you want to make it more secure, you actually cut down, let's say, access, which means it's actually a problem. So how do you make it very easy and seamless in inherent part of a development cycle? So what essentially kind of, the architecture we propose, and we actually try to say that, what, and this is why we reach out to various partners saying that security is a effort of collaboration. It cannot be done once alone. So one side, let's say IDs should have intelligence in terms of plugins, in terms of something we can create, which can give you static analyzing. That is already there, but then obviously you can create more analytical parameters. Then you can have a pre-commit hooks on your repository layer. Then you can have validators on your wallet layer, and then obviously on the blockchain layer. So this is the first part of the model. But then idea was, now let's do a risk scoring of it, because what essentially we have understood that we wanted to make it very simple. So without getting into how it's been done, we should actually, let's say, can we come up with a very simple risk score, and that can be used by anybody to first identify, okay, is it good or not, and then you go into that, go further to analyze that. So there are various kind of risk scoring algorithms available, which is depending on different kind of qualitative, quantitative, and simulative. So based on various kind of vulnerabilities, one simplest is weightage kind of based algorithm, where you can actually put various weight for your severities, and based on that you can actually create a risk scoring algorithm. So we're kind of, the second level is create a risk scoring algorithm, and that algorithm actually helps you to do a first level of analysis, that is it good or not. Because the one problem with this approach of plugins and this thing is too much of, let's say, text oriented, too much of data oriented, and you spend a lot of time to analyze the data. But the idea is, as I say, we want to make it very simplified. So how we make it very simplified? So first step is, let's create a risk score. So let's say the flow would be like that. There is some entity or some engine or something, some ML or some AI. It first immediately tell you that, okay, what is the risk score? Is it 40, 30 in the scale of 0 to 100, like that? And this solves a productivity problem. You don't have to go to too details of it, and then based on that you go forward and you understand that if it is too risky, then we can go ahead and analyze it. So this is where kind of risk scoring algorithm comes, where you actually, when you build a model, you should also kind of build a risk scoring around that, because that will be very simple for you to analyze and understand. So with this risk scoring, you kind of create a model, and then the next part is, depending on which layer where you to, we actually you can actually try to do a indexing. and kind of, ranking various kind of on-chain contracts. What essentially this will do, this will give you like a profiling of high risk versus low risk kind of thing. And this is where you actually, as a security analyst, you can automate this part. So think of it like that: you create a model which has this risk scoring analytics integrated as a model, and then you create this, wrap it with a crawler which continuously crawl through your explorers or various kind of blockchain, whatever blockchain you want to do, and keep ranking this, the various smart contracts. This could be a contract belongs to a same project, different projects, depending on what is your portfolio. If you're a VC, probably in Insta, you wanted to look into all the contracts belongs to your companies you have invested. So depending on that, you can do so. If you do this as a fully automated manner, then you get the first level of, let's say, report, where it says, what, I see kind of, let's say, average risk around 1200 contracts, which I need to look into. And then you go and deep dive. So security, as I say, you have to, there are a lot of times you spend time on something which is not important. So essentially here, what I'm trying to do, you're prioritizing your work in terms of what is important I need to look for in terms of security. And then you can deep dive and you can do automated further analysis in terms of that. So this is where the ranking algorithm comes, which you can use it. Now I just wanted to one second. Yes. So this part, this is the first part of the presentation, where what we're trying to build is in terms of a kind of a pipeline of overall ML ops or ML architecture, where you not only build a model, but you actually can create a complete end-to-end automated risk scoring platform, where it actually helps you to do a lot of manual tasks which otherwise you are doing today, and eliminate that with this kind of evaluation, so that you can focus on more further analysis on the advanced level of vulnerabilities, which is mostly into business logic and stuff. So this is the first part of the model. So is there any questions, or do you do like later? Anybody has any questions? Okay, so we'll move on. So the other part is, as I say, this is about creating a security stack. This is not about algorithms. Now, there is other tools. So the other part is, obviously you can actually have a lot of this kind of tool you can automate, like using Docker and container. You can do Slither. You can automate that, like a Mithril, or there is a smart bugs. There are a lot of other tools are there. But if you want to use, let's say, AI as an engine, you actually have to create a MLOps stack. When I say MLOps stack, as I say, it's AI is all about continuous learning. So let's say I have 100 odd smart contracts or 1,000 contracts today, which has certain kind of vulnerability which I have trained or I understood. But then tomorrow something new attack vector comes. I have to continuously flag and feed that data back into the system and kind of learn it together. So essentially, this is a continuous pipeline where you create a data lake first, where you keep pushing the data. It could be flagged, it could be labeled, it could be like unsupervised, and then with this data, you continuously train your model. So what essentially we have done on this is we have created an LLM, large language model, and what it does, and thanks to ChatGPT, obviously, it's nowadays even much easier, where you can actually do a kind of model by yourself. So there is two things I want to show you. So can you see this? Yeah, let me zoom it. So let's say this is called a LLM bot. I'll just quickly show you how this can be built pretty easily, and you can do it. So again, first part is you need data. So what essentially you do, first you create your data set. What essentially that means is, Okay, let me explain you the process, and then probably I'll try to show you how it's been built. So first I have, as I said, an initial research classification model what we built. We anyway have labeled the data. So we have created a repository or index of data, which has, let's say, hundreds to hundreds of different kind of vulnerable smart contract with specific vulnerability, reentrancy or any other kind of vulnerabilities are there. So we've created the repository. Now, in ChatGPT, you can create a bot where you can feed in the data. So you can actually say, you know what, you now gonna be a smart contract audit bot, and here is my data point. So we have created, so we have indexed and crawled through various kind of vulnerable smart contracts, and also we have created what is that vulnerability, what code part of the code has that vulnerability. We have created that as a data, and we feed in that data to the GPT saying that, you know what, this is what has been sampled, where you can see that how this has been exploited. That's number one, first stage. The second stage is pull out all the audit reports from everything is public, right? Pull out all the audit reports from all the companies and whoever published the audit report, right? And say that, you know what, this contract, this is the contract source code, and these are the vulnerabilities which it had. Why don't you kind of learn from that? And then you feed in all this data back to GPT, where there's a bot creation uh, flow. And once you feed in all this data, eventually this has the intelligence where you can actually say audit this smart contract, and it should be able to do a smart contract audit there. So let's say if I go to, let me try to go to, let's say, not Morph, maybe Polygon Explorer. Okay, let's go to Polygon Explorer. And let's say I go for, I don't know, top tokens, something. I'm just giving you some random thing. Let's say this is the code. I go to the contract, and obviously this, a lot of time this contract has multiple files, but let's say this is the contract. I'm just giving you a very simple, this is a very simple prototype. You can copy paste the code, and what I can do is you can say that audit this smart contract. I'm going to paste the code. So what it will do, it has actually kind of has intelligence of how it has been done, and then it actually can run and it can tell you, yeah, so what are the problems I can find and all these things, it can actually do it. So this is how we do, and this is done using the GPT bot creation feature. So actually, if you don't know ChatGPT, you can actually create your own bot. So you can actually create, okay, this is not the one, but okay, create here. From here, you can actually create a GPT builder. This is the one. And so you can say that, you know, so like that, you can create a smart contract basis. So again, you have to try it out. Obviously, it's not that always 100% perfect, but then once you do this, you create, and then in the configuration section, here you can go, and here you can name your GPT bot. You can say, let's say I want to create, let's say, and instructions are there. So you can create various kind of prompts, and eventually here there is a knowledge section. This is where you can upload files. This is where actually once you label the data, the one I've created, those kind of labeling data, which I've shown on my previous slide, you can upload those data here, and once it has those intelligence, you can actually create create your own bot there. So this is one part, and once this has been done, you can actually keep uploading the data later on as well, but this can actually give you a very simple chatbot which can create and which can analyze the quality contract and everything, and then you can create API around that and all this stuff. Last but not the least, there is also a kind of GPT based. Yes. So this is the most recent report, has been published on February 20th, just 5 days back, which actually is a very good reference if you are trying to build your own automated AI-based, let's say, audit bot. What essentially they do, they have evaluated kind of lot of kind of model, and with this, there are primarily 3 parameters which you look into: vulnerability detection, code parsing capability, and then POC writing ability. Because the other challenge in kind of smart contract audit is not only detecting the vulnerability, but eventually we have to create a POC. Especially if you're a bounty hunter, if you're doing bug bounties and all this stuff, you need to create a proof of kind of POC code, which will able to exploit that and show you that this is exploitable. So how do you kind of not only find vulnerability but create an audit? So essentially with this, you can create various kind of model, and this is a very good reference where, so we managed to create a kind of a smart contract, a good chat GPT prompt, which helps you to create a smart bot, which will give you a more efficient result. So, so in a nutshell, thanks to GPT, there are a lot of things which is much easier. But then, if you have to do it in a basic fundamental way, you have to start from the beginning of collecting the data, labeling, cleaning the data, and then creating a lot of models on your own. If you want something, you have access to ChatGPT or ChatGPT Pro, you can create your own bot like this, and that can also help you to do a much faster analysis. Now, this analysis was able to create and identify a lot of good vulnerabilities, and it is much scalable, obviously, because they can do audit much faster. So I think in this research, they are able to audit like, I think 34,000 smart contracts in quite a faster time. I don't remember exactly, but they have published the data report here. So with the interest of time, I'll stop here. But this is a very good reference of how you can create a much efficient LLM model for audit. So yeah, I think that's pretty much what I have. Yeah, thank you so much. If you want to connect or talk, happy to get connected. Yeah, later after the talk. Thank you.